Good day, Miss. My name is Tenyola, and today, sorry, I'm going to be answering the question engagement for our conversation assessment. For this assessment, I'll film a video. My goal is to convince you basically that my elephant population should receive funding. You will discuss name of country and population, size of area, example of density dependent, that's independent, why data support needs for conversation, conservation for the any other persuasive information. So I'm going to go here. Now, the country you gave us for the observation was Mozambique. Now, from what I've said, I think this area, which is called Nisa should receive funding. Why? Because from my research, I found out that the elephant population in Nisa is facing extinct is the elephants are becoming extinct in this area because of pediatrician, which is a what I mean by pediatrician in this case is hunting of elephant, which is a density dependent factor. The also density depend the other density dependent factor like competition and disease, but that's the main one that affects it. So, and from the internet, as I said, the elephants there in this area are facing extinction. As you can see from my graph here, um, you can see here that like okay, so as you can see from these two graphs here with the this is elephant population in Tetse province, and you can see that when the bush reached the peaks, which was 20,000, which was in 2009 for Nista NR, and why am I talking about the peak? I mean the when the elephant population stopped growing. So according to the table. So in 2009, the peak for elephant population was 20,364. In 2003, the peak for elephant population was 61,628. Now, this is when the elephant population started decreasing. Now, as you can see from here, from 2003 to 2014, it did decrease that much. The elephant population here, it decreased, but it didn't increase that much. But from 2009 to 2014, this population decreased far far more than this population. From 20,000, from 20,000, it became 4,000 in 2014. In 2003, from 1,000 it became 1,050. From 1,628, it became 1,051, which is a decrease, but is not as worse as this decrease. So that's another reason why it must receive compensation funding than this area must receive conservation funding than this area. Also, as you can see here, the stratum area, which is like 42,126 kilometers square, is way more than the Texas province area, which is 2,718 kilometers square. Now, that also means that this this area poses a large number of elephants because it has a large area, and also it means it's more stable, it's a stable environment than this one. And you can see for numbers that even though it decreased in 2014, even though this from 90, even though the elephant population decreased so much, it was still the elephant population here was still larger than here. So that's another thing. Also, here's my curve. So my curve doesn't feature any exponential or logistic graph, but you can see here there's a peak. From this peak, it just started decreasing until in 2014. Then any other thing? Okay. Also for density independent factors, something like weather, oxygen levels, or temperature. Now, I didn't really find anything on weather because the weather correlation didn't correlate to the NISA and now decrease in population. So I don't think any density independent factors can result to this. Or maybe because of greenhouse gases, that the rise in greenhouse gases, it has reduced. No, sorry. So there's nothing, no density independent factors correlating that will cause a decrease here. So for density independent, I already said it was hunting, which is also prediction. Um, that's all I have for you today, miss. Have a nice day. Bye.